Do you know about the so-called BowBomb exploit, a hack to do massive damage with a bow and arrow? Well, in this video I want to talk about it. This is part 3 of covering known Minecraft hacks that I thought were kinda new but apparently already existed. So if you find this interesting, check out the previous 2 episodes about the reach hack and the 2b2t cat coordinate exploit. But now, a quick refresh on the background for this video. On my Minecraft server, I implemented a high score challenge where I measured the velocity of a thrown snowball, and the player with the highest score gets a shoutout. So why is this an interesting challenge? Well, that's because the initial snowball speed is determined based on the velocity of the player. This means, for example, when you are falling, so you have a large downward velocity, the snowball is thrown faster compared to when you are standing on the ground. So, if somebody dominates the challenge high score, it could be proof that an exploit exists allowing you to get much higher velocity speeds than just from falling downwards. Of course, throwing snowballs is not that interesting, but the real reason why I want to know if a player can easily gain a lot of movement velocity is because the velocity is used in the player movement logic. Specifically, the higher the velocity, the larger the distance between two movement packets can be. And theoretically, if you could get arbitrary high velocity in the game, you could essentially move or teleport yourself anywhere on the map. So, does an exploit like this exist? Let's find out. When I talked about this challenge in a previous episode of Minecraft Hacked, immediately people were saying, lame, this already exists in 2b2t, it's called BowBomb. So let's see if that is true. But instead of downloading an existent hacked client to do it like all those skits do, let's properly investigate this. We are here to hack, not to cheat. Alright, it gets technical now. Let's approach this analytically. First of all, it has to be clear that whatever happens on the client does not mean it's also happening on the server. For example, in a Minecraft client mod, you could just manipulate the player velocity directly, and it looks like you have velocity. But that has no real effect on the server, and this becomes clear when you look at the Minecraft protocol. There exists no packet sent from the client to the server indicating your velocity. All there is a position packet. So you only tell the server your position, not your velocity. Now, velocity in physics is defined as the rate of change in position. So you could think of changing your position in a short amount of time, for example with a fly hack and high speeds, going from standing still to fast flying. That would mean massive velocity, right? Well, in real physics terms, yes, but not in the way how Minecraft uses velocity. So how does Minecraft movement actually work? On the server, there are basically 2 different values regarding the player movement that are important. That is the position or the location, and there is the delta movement. The position is of course just your current coordinate, and the delta movement is your velocity. Delta movement, change in movement. But as I mentioned, I don't get delta movement from just moving. Delta movement or velocity is only applied in very specific situations. And those are, for example, when you get pushed or pulled, when an explosion happens, when you get knocked back, or when you jump. Only these kind of actions apply a delta movement to the player or other entities on the server. So while the position of your player is directly controlled by your client sending the position packets, that's why you can easily fly around, the delta movement, the real velocity, is only indirectly controlled through actions like jumping. So it's kind of unfortunate, and unfortunate for hacking, that the velocity is used in various interesting places. For example, in the movement packet handling. A high player velocity would allow player to basically send very large position changes and teleport around. Or it also affects the initial speed of thrown snowballs and shot arrows. And now we understand what the goal is of a hack like BowBomb. Somehow you need to do something that gets the server-side player delta movement very high and then shoot an arrow, and then that arrow is doing a lot of damage. So, how does the BowBomb exploit work? How is it possible to get super high velocities for high arrow damage? Well, as I mentioned before, the server-side velocity is modified by things like jumping. And there lies the secret. Here is the jumpFromGround method. This code handles jumping, and have a look here at the comments. This is code added by the paper server. If we remove that for a moment, we can see what vanilla Minecraft code looks like. Let's see what is happening here. If the player jumps, we get a jump power value and the current velocity, and we combine them. This is a basic jump upwards, small upward velocity. But that is not all. If we are also sprinting at the same time, then we modify the delta movement again. We are sprinting, maybe we want to add a little bit more boost for the jump, so it gets the current delta movement and adds to it this value, allowing us to jump a bit further while running. And this can be exploited. If we add here values, what prevents us from adding values over and over? And that's how the arrow damage exploit basically works. By repeatedly jumping, potentially many times per tick, each jump adds a little bit of delta movement. And if you look into the source code of random BowBomb implementations, that is what you can find there. The code here first sends a packet to start sprinting, and then in a loop sends alternating on-ground true and false packets with a small y value higher. Those are basically micro jumps, and this is what triggers the jump from ground on the server. Pretty straightforward. But also this does not work to get arbitrary velocities, because the delta movement velocity is also lost over time. So at some point the loss is higher than the gain from the repeated addition. But it doesn't matter in this case. You can get your velocity up quite a bit, enough for high arrow damage. So were they right? Does the arbitrary velocity exploit exist? Well, remember, this was only vanilla Minecraft code. Let's add the paper patch back in. Now we can see that this add to the delta movement only happens if the can crit variable is true. And this is set only after a cooldown. It looks at the last time you jumped, and if less than 0.25 seconds have passed, can crit stays set to false. Only jumping after 0.25 seconds you can get into this if again and can crit is true. But by that time the previous added velocity is lost again. So you can see this known velocity exploit is patched on paper. It does not work on my server. But is it really? Actually, if we look at this, this is exploitable in low TPS situations. Minecraft servers should run at 20 ticks per second, and loss of velocity is also calculated in those ticks. But this cooldown here is based on time, not on ticks. So if we get the server down to a crawl, where each game ticks takes a lot of time to execute, at least 5 times slower, basically a quarter of a second, then we could send multiple jumps and build up velocity. So theoretically, there is still a way to exploit it, I think. However, it's not easy, because to pull this off, you need to precisely control the TPS. If you get the server too slow, then the watchdog kills the server. So you have to very carefully lag the server. And if you want to use that in an actual PvP fight or so, you need to find a really good bug to lag on demand the right amount. So it's more theoretical than practical, but it's something to think about. And I do wonder about the Snowball challenge. Somebody should do the math if you can beat the high score this way. It could be a really cool proof of concept. So if you develop a working exploit on your own server and then want to try it on the LiveOverflow server, of course you can do that. I want to see if it can be pulled off. Alright, now let's come to the community showcase. This one is by TudbuT again, showing off his SeedOverlay. Take it away.
So this is SeedOverlay. So you can see that there are such red tints on some blocks. For example, this one has a red tint, this one has a yellow tint, and this one has a green tint. And this is because this block wasn't there in the beginning, and this block was different in the beginning, and this one was there in the beginning. So it can detect when there was any kind of player activity. When a block changes, it's yellow. When a block is removed, it's red. And when a block is added, it's green. You can see here that I have a lot of changes made here. And here's a little bit of the tunnel. And for example, in the Nether on Anarchy servers, you will often see such tunnels like this in the Nether ceiling or in the Nether floor. And this is very useful for finding bases, because such 1x2 tunnels are often used by people who don't want to leave much of a trace to their base. But by doing this, they actually leave much more of a trace to their base. And I can follow it and see that in this case, this is just made by me, so there isn't much to see here. For example, if I were to block this off right here and were to make people, or try to make people think that the tunnel ends here, it's also pretty obvious to that person that the tunnel does not actually end there, because they can basically see through it. Yeah, that's pretty much the entirety of SeedOverlay, but I think I would like to show some code of it also. Basically, it is just a module in my client, and so first off, this module has a static function that will add some blocks to a list of blocks not to include in checks, and whenever either the current or the original block is any of these, it will be ignored, which can be quite useful, I think. And then we have a function that checks for the original and the old block, and if they do not match and they aren't excluded, then it will put that in the toRender hash map, save that toRender hash map to be rendered. And then there's also the create fresh world copy, which is where it actually gets interesting. Here it takes a seed and some world info, and this world info and seed is then used to create a pretty much identical world. The only difference is that it is running on the local client using an integrated server, which World Generator v2 is basically just a copy of. And it also doesn't have any of the information when which chunk was loaded, sadly. When players have loaded chunks in some special orders, trees, for example, get mixed up and they turn out to be at the wrong locations, depending on when this chunk was loaded. And so that's why I have this exclude list, which excludes trees and other features, decorations, whatever. I think they're called decorations in the code. That's basically what it does. There's also some other things that render the whole blocks thing, but that's relatively simple. But another thing that I would like to show is the world generator provider, which is the old version before I switched to just copying the integrated server. This one was actually more capable because it even worked in single player, while the integrated server, only one of those can run at a time. But this one was actually able to run alongside the integrated server and therefore work in single player. The issue is that the chunk class, or I think some class in the chunk generation pipeline, is using static fields for data storage, and when two chunks generate at the same time in single player and in the SeedOverlay, then it'll cause either the single player one or the SeedOverlay one to corrupt and basically just completely mismatch. And I didn't want that because it would actually corrupt single player worlds, so I switched to the integrated server one, but I kept this one for whenever I might need it in the future.
This is a school, and do you know what you learn at school? You learn how to write by hand, which is terrible. Nowadays, there's the LiveOverfont, a handwritten font, much better than what you learn at this crappy place.